Okay, welcome to the Introduction to Electromyography, also known as EMG. So again, we introduced, I think our first day of class, electromyography. It's one of the EGs, so it's measuring electricity in a graph, and the myo in the middle is standing for muscle. So in this lab, we'll be measuring muscle, specifically the electricity that is coming out of the muscle that can be measured at just the surface of the skin. So we're not actually putting probes deep into your muscle to measure that electricity. So we'll be going into some detail about the muscles we'll be measuring. I did want to highlight, because this is the first lesson in our modules, and I wanted to highlight what is important for you to review before you take the quiz in EMG. So each module is going to bring with it a quiz, and what you need to do is, what I'm going to be talking about in this particular video is somewhat duplicated but also important for you to read, the introduction PDF file. So I have these PDFs loaded into the module section. So it's very important, and depending on what kind of a learner you are, you might prefer to watch my videos first and then read the introduction, or you might prefer to read first and then watch these videos. But they're meant to be complementary. I kind of extract information out of the introductions and kind of highlight them here, and it gives you a better sense of what I think is important to know out of those introductory pieces. So from that introductory PDF file, you'll find that there are 3 basic muscle types, and I'm going to pause to give you a chance to try to recall. If you're one type of person that read it first, try to recall what those 3 muscle types are. And they are cardiac, smooth, and skeletal. And then we're going to kind of go through. So the cardiac muscles are heart muscles. The smooth muscles are typically seen in the walls of the hollow organs. So these are our intestinal muscles, blood vessels, and lungs. And then the skeletal muscles are attached to bones. So they are typically what's involved in voluntary movement. They're also called striated because they look like they're striped. And we'll be looking at some graphics that give you a sense of how that looks in a minute. So the basic process, you probably know this from other classes, the motor sequence of motor impulses that end in you flexing a skeletal muscle starts in the brain. It sends the motor command. Then it is relayed by either cranial nerves if it's sending information to muscles in the face, for example, or down the spinal cord if it's sending information lower down to the arms or legs, etc. And then the axons exit the spinal cord in nerve bundles, and they innervate, they provide nerve impulses into one or more muscle fibers. And we're going to look at a diagram on that in a minute. The muscle fibers receive the motor neuron message, and they are cylindrically shaped. So as I was kind of trying to understand that when I was first learning this, I was having trouble visualizing a cylinder-shaped thing inside of one of my muscles. So I dug up an illustration, and this kind of helps you visualize how that looks. So these are like super long, skinny cylinders, if you have to use that way of thinking of it. And again, this is your motor neuron, and it's leaving the nerve bundle, and it's innervating one or more nerve muscle fibers here. So some, like this one, for example, all of its pieces are on just the one muscle fiber. But this one here, you can see it's innervating 2 different muscle fibers. So we're going to go into a little bit more detail about how that works. So I extracted this from the introductory PDF that I referred to before. And rather than just having to look at that whole thing and try to break it down, I thought it would be helpful if I could break it down for you. So we're looking straight down somebody's spinal cord from top down, and there's the back of their spinal cord, and this is the front of the spinal cord. And so the nerves are kind of exiting the front side, the anterior root, and then the motor nerve is exiting here. And then this part is where we kind of need to focus in on. We're looking just, they've kind of highlighted into one nerve fiber here, and then I'm going to blow up here a little bit more in detail. So I'm going to give you the next slide. So you can see now we've kind of skipped over here. Here's our nerve, and it is apparently, by their diagram, innervating 3 actual muscle fibers. So it's supplying information to those 3. So the way they're describing it is the motor unit number is 3. So here's our motor unit. It's the nerve fiber, and it's the 3 muscle fibers that it is supplying information to. So there's our motor unit right there. So muscles maintain what is called tonus. And this is going to be in your lab report. You're going to need to have an understanding of tonus, because part of this lab is you'll be measuring yourself in tonus. So tonus is actually this constant state of slight tension. So we typically think that when we're flopped out on the couch like a couch potato, that our muscles aren't working. Actually, a tiny little bit of muscle is working kind of in cyclical fashion. So it's this sense of readiness, so that if the muscles were needed to be called on, the muscles themselves wouldn't be completely asleep. There would be some activity going on. And this tonus is maintained by this alternate activation across the different motor units. So just a few tiny little motor units at a time are staying active, and then they're kind of rhythmically taking turns who's active. But that allows us to have that state of readiness that is important that tonus provides. So now we want to look at the amount of a muscle contraction. So in our introductory lesson, we talked about the fact that, again, we know that the nerve impulses are kind of all or nothing. So how do we get from this all or nothing nerve impulse to the fine gradations that we can get as we flex our muscles? Because we don't flex all or nothing, we flex lightly, we flex stronger, we can influence how much we're flexing our muscles. So we have 2 ways to kind of control that. One relates to the frequency of the motor unit impulses. So how often are these motor units firing? So if more energy needs to be garnered, then we will have more frequent motor impulses. And then the other part has to do with how many motor units are recruited for the particular task at hand. So if you have to lift something incredibly heavy, your body is going to recruit as many motor units as it can get its hands on. So the number of motor units gives us those degrees of contraction strength, and that's going to be what you'll be measuring in your lab. So as you change these 2 things, this is referred to as grading. You're grading it up and down. You're giving it kind of a range of intensity, of clench strength. And so it's called motor unit recruitment when you're increasing the number of motor units you're engaging. So that's going to be an important thing to know as you work through this lab. Now, so we talked about the amount of contraction and how it's controlled. Now we want to kind of pivot to how do we measure the amount of muscle that is how much muscle is contracting. And that, I challenge you to think of how we might measure that. Well, that's the name of this lab, electromyography. So electromyography is interested in measuring how much contraction is happening at any given time. So the last piece I will try to cover in each of these labs is, so this is the introduction to the lab and kind of the conceptual pieces of the lab. I'm always going to try to tie it back to why are we doing this in a psychology class? And so one thing to recognize is what we call skeletal muscles. We typically think of biceps, triceps, forearm muscles, things that are big and have gross motor movements. But it's important to realize that we have a ton of muscles, including like the muscles right above our eyebrows here that control frowning. And so you can imagine how helpful that might be in a psychology study. So you can measure the strength of the muscle contractions for the frowning muscles. People have done it for the smiling muscles, so they've done a lot of studies to see how much people move their facial muscles, and therefore they're trying to get a gauge of something going on psychologically within the person. In our lab, in the Mind Body Lab, a couple of my colleagues have been studying different fear responses that people have, and they're measuring the muscles on the eyes themselves, and this, what they're measuring is the strength of the eye blink that people have. And this eye blink startle reflex tends to be very tightly calibrated to the degree of stress somebody has, the degree of fear they have. So the bigger, stronger the contraction of the eye blink, the more stressed out they are. So there's a lot of applications for EMG and psychological research, and that's just a few examples.